So we are doing advanced paper 1, question number 13. So it says that this question is from sound interference. This question it says that there are 4 options, and in each options a certain case is given. So we'll take the case one by one. So in first case, the diagram is something like this. This is option number P, and there is a detector here, and there is a source here at point S. Now we have to find out the minimum value of L so that there is a maxima here. So I know that for maxima, path difference is equal to n lambda, and since they are asking us for the minimum value of L, we'll take the value for n as 1. Okay, so I'll write the other given values as well. This is equal to 0.5L. Now, I have to find out first of all the path difference at point D. So, path difference technically is what? The path taken by wave from here to here minus the path taken by wave to travel from here to here. So, path taken by wave to travel from here around a semicircular path is pi r, pi times r, minus L, and r is given as 0.5L. So I'll keep r as 0.5L, and this should be equals to n lambda, and the value of lambda is given in the problem as 0.29 meters. So this becomes pi. You can take L common. So this becomes pi by 2 minus 1, and like I said, for minimum value of L, we'll put value for n is equal to 1. So this becomes lambda, and lambda is equal to 0.29. If you simplify from here, you'll get the value for L as 0.508, which upon rounding off, you'll get the value as 0.51, and that is option number 3. So I got P is equal to 3. Now I'll do the next case, that is Q. So in Q, it is given a rectangular pipeline like this. So our source is here and receiver is here. The value is L. This value is 0.5L. Now what is the path difference at point D? Path difference at point D from S. Again, light wave, sound wave here can travel via this path. That is path number 1. And second is straight wave from here to here. So path difference becomes this plus this plus this minus this bottom path. So delta x becomes 0.5L plus L plus 0.5L minus L, and that is equal to n lambda. Now you can see L and L cancels out. This becomes just L. So L becomes equals to lambda, because n is equal to 1. It will be for all the cases, and I'll get the value for L as 0.29 meters, and that is in option number 4. That means Q becomes 4. Alright. Similarly, I'll do the third case, that is R. So in R, the arrangement looks like this. Source is here and receiver is here. So here in path number 1, the wave will go like this. and in alternate path the wave will go straight like this. So path difference becomes path from this straight path plus semicircular path minus this straight path. So here delta x becomes, this length is given as L, this length is given as L. So L plus pi into R, L plus pi R, where this value is equal to R, minus L, and this is equal to again and lambda. So you can see L cancels out once again. Pi R equals to lambda because N is equal to 1. I explained that earlier. Now now the thing is we have to find the value of R from here. So if this is L, this is L, the diameter becomes root 2 times L. So 2 times of R becomes under root 2 times of L. So from here R is equal to L upon under root of 2. This 2 comes over here. So L upon under root of 2. So I'll put pi into L by under root 2 equals to 0.29, and from here this becomes 0.29 multiplied by under root of 2 upon pi, and pi is equal to 3.14. Now when you simplify this, you will roughly get the calculation around 0.13 meter, and this is option number S. So now there is no need to solve for option S because now we can eliminate the options. So we can see that option D is matching. So P is equal to 3, Q is equal to 4, R is equal to, oh sorry, it's 5, not S. R is equal to 5. R is equal to 5. So there is only one option present like that, and that is option number D. So answer becomes option number D. But if you have to solve for S, similarly we can solve for S. I will draw the diagram. So similarly, if we have to do for S1, okay, so source is here, detector is here, so path difference becomes this path number 1 plus path number 2 minus path number 3, and using component value we can find out the result. Okay, fine. So this was question number 13. Now we are going to discuss question number 14. So question number 14th is a theoretical question. Advanced paper 1, question number 14. Yes. So in question number 14, there are two lists. Okay, list number 1 says colorful sky, in north, polar region. Option B says partially polarized sunlight. Options, okay, it's PQR, right? P Q R. Option R says rainbow S is dark and bright fringes. Now guys, we know that dark and bright fringes, this is in wave optics chapter, and the reason for this is interference and diffraction. So in this question only diffraction is present. So for this answer becomes diffraction. Rainbow. Now rainbow is about dispersion. When a white light passes through a drop of water like rain falling, the colors are dispersed. So along with that, there is partial reflection in atmosphere as well. So rainbow becomes dispersion and reflection. Okay. So now if you look at the options, rainbow becomes, R becomes 1 and S becomes 3. So R is 1, S is 3. So it is present in only option A and B. Okay. Now going to the first one, colorful sky in North Polar region. Again, it's a theoretical question. The reason for this is emission of radiation from oxygen and nitrogen atoms, right? Around polar regions where the pollutant concentration is minimum, and you will find nitrogen and oxygen in more abundance over there. So this P answer becomes 5. So this P becomes 5, and you can also do reverse engineering and eliminate. In option B, Q is given as 2, which is not possible. Partially polarized sunlight. It's not due to total. So we are discussing question number 15 now. So in question number 15, you can see in left hand side column, it contains 4 conducting loops. All right, and the magnetic field is in positive z direction. Okay, so suppose if I draw a diagram, something like this. And magnetic field is outwards. Now think it like this. So this is the current positioning of loop. So from here till the loop attains this position, like it is rotating, right? So till it rotates from here till here, the magnetic flux through this loop will be 0. Magnetic flux will only appear when this loop is not totally, like it just leans from vertical into rightward direction, and it is totally horizontal like this. Okay, so for this part, understood? So we can see that the current will be there for half the time. Option number 3, can we show option number 3? Yes. So current will be produced for half the value of positioning of the loop, for half the positioning. For the other half, again magnetic field the current becomes 0. So only one option is justified here. And yeah, there is a word used here, induced current. So you may think that Lentz's law will be applied over here, but they have not mentioned about whether to take the direction of anti-clockwise current as positive or the clockwise current is positive. So taking all the conclusion, option 3 is the best option. So for P, it becomes option number 3. Okay, we'll go up to the yes. Now you can see the diagram number Q. So similarly, for diagram number Q, the loop looks like this. This angle is 60 degree and this angle is 60 degree. Okay. So now for 360 degree, there is a complete T. So for 60 degree, this becomes T by 6. So the current will be there for T by 6 when again you can imagine this part of loop comes inside and there is nothing here. So current will be always 0 here. Okay. So going by this logic, you can see option number 1. Option number 1. Go up. Option number 1. Okay. So for Q, it becomes option number 1. Now the third diagram is third diagram. Yes. So third diagram. This is 60 degree. Now here the current will be only for, again you can say T by 6. So for T by 6 there will be current and for the remaining there will be no current. Can you show option number 1 and 2 once?
1 and 2.
No, for Q answer will be option number 2. Sorry. For Q answer will be option number 2 because there are two loops like this, no? So current will be initially non-zero, then current becomes 0 here and then current becomes non-zero. Okay, so this is the diagram for 2. So for the previous one, this one. It is also 60. So current will be there for this much part, there is no current for this much part, and again there is a current for this much part. So there is a current for the first T by 6 part, then current for the last T by 6 part, and there is no current for this part, So here, and this is your current over I. So this becomes 2. And for R, the diagram is like this. So for R, it becomes option number 1, right? Because option number 1 there will be current only for T by 6 part and no current for the remaining part, right? So it will be like this. And when the loop goes downward, exact same current will be negative. Okay, which is there in all the options 3, 2, and 1. And in option number R, option number S. Option number S. Can you show me the S diagram? Yes. The diagram looks like this. The diagram looks like this. So this is 60 degrees. So whatever current will get for this, exactly opposite current will get for this. So the net current will be 0 here and we'll get option number 4. So S becomes option number 4 and the diagram would look like this. Okay. So which option is there? P3, Q2, R1, S4. Option C is correct. Thank you.
Hello. So today basically we are going to discuss that JEE Advanced Paper 1 question number 16. Okay. So in that question it is given that to find the moment of inertia of the different type of structure of the rods. Okay. So if moment of inertia of rod about an axis at an angle theta at the center so it will be like I equal to 1 by 3 ml square sin square theta. So we will go from the one by one from the structures. So first one is we will consider the P diagram. It is given like this. So it is making an angle 45 degree with the center. So I can say take this one as rod 1, this one as the rod 2. Now, so I will count I total will be I1 plus I2, that will be 1 by 3 ml square sine square 45 plus 1 by 3 ml square sine square 45. So I am getting 2 by 3 ml square sine square 45 is 1 by root 2 square, that will be 2 by 3 ml square 1 by 2. So I am getting the one that is ml square by 3. So basically P matches with 5. P matches with 5. Now second one, Q will be now the diagram will be given like this. Now this is given 60 degree angle, this is given 60 degree angle. Now if this is L, this is L, this is L, can I take this perpendicular distance for this rod 3 will be root 3L by 2. Now, so my I total will be, let's take this one is rod 1, this one is rod 2. So I1 plus I2 plus I3. So this one will be 1 by 3 ml square sine square 60 plus 1 by 3 ml square sine square 60 plus I3 will be ml square. So here m multiplied with that distance will be root 3L by 2 whole square. So if we will solve, here we are getting 2 by 3 ml square sine square 60 is 3 by 4 plus 3 ml square by 4. So final answers we are getting, that will be 5 by 4, 3 will get cancelled, 2 by 4 is 1 by 2 plus 3 by 4. So we are getting 5 by 4 ml square. So this one is the I total for the Q diagram. So Q matches with 1. Now we will do the R and S. Now R diagram will be given like this. Then now here 4 rods are there. R1, I can take R2, I can take R3 and R4. So I total here will be 4 into I, directly I am writing 4 into I1, that will be 4 1 by 3 ml square sine square 45. Done? Because these angles are given 90, 90, this is 9, total 90, so this one will be 45, this one will be 45. So it will be 4 into 1 by 3 ml square sine square 45 is directly I am writing 1 by 2. Directly I am writing 1 by 2. So this one I am getting I total will be 2 by 3 ml square. Directly I am writing 2 by 3 ml square. So R1 matches with 4. R1 matches with 4. Now S. S diagram is given by rods are like this, arranged like this. This one is rod 1, this one is rod 2. This angle is given 30 degree. This one is given 30 degree. Done? Now I total will be, I will write I1 plus I2. So again I am writing 1 by 3 ml square sine square 30 plus 1 by 3 ml square sine square 30. Done? So this one will be 2 by 3 ml square sine square 30 is 1 by 4. So I am getting 1 by 6 ml square. 1 by 6 ml square. So S1 is matches with option number 2. So I can write the correct option is option number A. That will be P matches with 5. P matches with 5. Q matches with 1. R matches with 4. And S matches with 2. This one. Done. Thank you.